So you should have previously watched a about 4-minute video on Canvas that kind of introduced you to the idea of parametric equations. And so just briefly, a parametric equation, say I have some projectile motion, something's launched into the air. This projectile motion has a horizontal motion and a vertical motion. And so what we do is we write two equations. We write an equation that's based on x for the horizontal and y for the vertical. And both of these x and y's, it's going to be x of, we're going to use t in this case, and y of t, where the t is the parameter. The x distance and the y distance is dependent upon the t. In this case, time, because how long the object has been moving will tell you how far horizontally it's moved and how far vertically it's moved. This is all explained out. You can read through the top of page 119. We're going to come back to 119 tomorrow in the video, but what we're going to do is we're going to skip to page 120, and we're going to talk about converting back and forth. So go to page 120. So on page 120, you'll find these converting from rectangular form, eliminating the parameter steps. So what we're going to do is we're going to start with this example 3. We're going to start with letter A, let's just get an easy idea what's going on. So it says that I have x equals 3t, and then y equals t plus 7. So step 1 says you start with a set of parametric equations. That's this right here. Step 2 is we're going to solve one of the equations for t. It doesn't really matter, but since I wrote the x one first, I'm going to solve the x one. So if I divide by 3 and divide by 3, x over 3 equals t. Then you substitute this into the other equation. So I'm going to take what I just found, what t equals, and I'm going to plug it into my other equation. So I'm going to have y equals, and I have my plus 7 at the end. But instead of writing a t, I'm going to write x over 3. And magical algebra steps, in this case, there's no magic algebra to do, but I'm going to rewrite this so you can see this. Y equals 1/3 x plus 7. This right here is my rectangular form. But not only that, you can tell me this is a linear equation. This is my slope, and this is b, my y-intercept. So this parametric equation right here and this one right here would have made on a graph this rectangular equation that you're used to graphing. And tomorrow, that's going to be helpful information because we're going to graph parametric equations by hand. Letter A was pretty simple, so I'm going to warn you up front. Letter B is a little bit trickier. So let's go on to letter B. So letter B says x equals 1 over the square root of t plus 1. Y equals t over t plus 1. So here's my first word of advice. The y equation has 2 t's in it, and the x equation only has 1 t. So I'm going to pick the x equation to isolate t because there's only 1 t. So I need to get this t down here, and it has a square root on it. So I'm going to square both sides, and as long as I do it to both sides, it's fair game. So I'm going to get x squared equals, you square the top, 1 over, and then square and square root undo each other, so you get t plus 1. I'm going to multiply over the t plus 1 on both sides. So now I have t plus 1 times an x squared equals a 1. And I'm going to divide by my x squared and divide by my x squared. So now I have t plus 1 equals 1 over x squared. And then I'm going to subtract 1, minus 1, minus 1. And so I'm going to get t equals 1 over x squared minus 1. And technically, that's all I needed to do to get the t by itself. But I have a little bit of mathematical experience. And so just from this experience, what I want to tell you is I have a fraction and then a whole number that I'm going to plug into a fraction in a second. And so before I do that, let's make this a little bit more cleaned up. So what I'm going to do is I'm going to say t equals 1 over x squared, and I'm going to change the 1 minus to an x squared over an x squared. X squared over x squared is the same thing as 1. I have a common denominator. And because I've done that, I now can put this together and say that t equals 1 minus x squared all over x squared. So now this beautiful thing right here is what I'm really going to plug in, because algebraically it will make my life so much easier. So let's go ahead and do that. So I'm going to have y equals, and on top I have a t. So on top I'm going to put 1 minus x squared over x squared over, on the bottom I have another t, 1 minus x squared over x squared plus a 1. I'm going to do the same trick again right here to this 1. I'm not going to call it a 1. I'm going to call it an x squared over an x squared, because then my denominators in the bottom are going to be the same. So I'm going to have y equals 1 minus x squared over x squared on top over, right here, let me grab a different color, negative x squared plus an x squared makes those x squareds cancel out. So what you're going to have on the bottom is just a 1, and their common denominator is x squared. And then I get to sing you my favorite song. If you are not my pre-cal student, I'm so sorry, but my pre-cal kids are so used to me singing this. Dividing by fractions is easy as pie. Flip the bottom and multiply. So, oops, sorry, need my pen. So what I'm going to have is y equals 1 minus x squared over x squared times x squared over 1. I took this, flipped it, and multiplied. Then what happens is this x squared and this x squared cancel out. So you're left with y equals 1 minus x squared over 1, which is the same thing as y equals 1 minus x squared, which is also the same thing as y equals negative x squared plus 1. Either one of these are right. But what we've done is we've eliminated the parameter. There is no more t. We just have a rectangular equation, and we know that it's rectangular because it has an x and a y. No t, no parameter at all. No parameter, not a parametric equation. You should be able to tell these green boxed equations, it's a parabola. It moved up 1. That's what this piece did right here. And this negative piece right here at the bottom made it flip upside down, so it's opening down. So what you started with up here, this equation and this equation, when you graphed them in parametric form, would have made this rectangular equation down here that you know is that parabola. Okay, so the one thing that's not explicitly in your notes right here is how to go the other way to convert from rectangular to parametric. So I'm going to give you a problem. This problem is posted on the PDF on the assignment side of today, but let's do a problem together. So just find a little bit of blank space, maybe on page 120, and you can write this problem down. So we're going to do number 6 on the paper that was posted, and it says that x equals negative y squared over 3, and t equals y. So this is an easier example. So in this problem, this is in rectangular form because there's an x and y in the same equation. And what they're saying is this is the parameter. So they want you to use this parameter and plug it in the other way to make two equations, the parametric equations. Okay, so in this one it says that y equals t. So we're going to use this y equals t, and we're going to go plug it into the other equation. So I'm going to have x equals, and instead of writing y equals t, I'm going to write negative t squared over 3 because this was a y and y equals t, so we plugged it in. So again, this was a very simple example, but your final answer looks like this. You're going to have x equals t squared over 3, and then y equals t. Because when you have a parametric set of equations, you should have a y equals 1 and an x equals 1. So let's do one that's a little bit trickier. Let's try number 10 on the practice worksheet. So number 10 says y equals negative x squared over 6. So this is my rectangular equation because it has the x and the y in it. And then my parameter, I know it's my parameter because it says t equals, is going to be negative x over 2 plus 1/2. This is my parameter. So I need to take this parameter and I need to be able to plug it in. But to do that, I need to solve for x because there's an x in the top equation. So the first thing I'm going to do is I'm going to subtract the 1/2 over. So I'm going to get t minus 1/2 equals negative x over 2. And then what I'm going to do is I'm going to multiply the whole thing by a negative 2. I want to get rid of this 2 on the bottom down here. And since there's a negative on top, that will take care of the negative as well. So I'm going to multiply everything by a negative 2. So you're going to get negative 2t. A negative half times a negative 2 is going to make a positive, and half of 2 is 1 equals x. So there's my x equation. So now I need to take my x equation and go plug it in up here. So when I do that, I'm going to circle this so I don't lose it. I'm going to get it in a second. I'm going to get y equals negative parenthesis, negative 2t plus 1 squared all over 6. And in some cases, they will take this and FOIL it out, this top part right here. So good algebra practice. Let's go ahead and do that really quick. So to do that, I'm going to leave the negative out front for a second. And what I'm doing right now is I'm going to do negative 2t plus 1 times negative 2t plus 1. I'm going to FOIL it together. So I'm going to get a 4t squared minus a 4t plus a 1 all over a 6. And then I'm going to take each piece and separate it and give it the negative. So I'm going to give this negative inside to all three pieces and divide each by a 6. So I have negative 4 over 6 t squared minus 4 over 6t plus, oh, sorry, no, hang on, back up. Did not do the negative. Okay, so I gave the negative to the first one. The next one's become a positive 4 over 6t, and the last one would become a minus 1 over 6. So I'm going to write my cleaned up equation. It's going to be y equals 4 over 6 reduces to negative 2 over 3 t squared plus 2 over 3 t minus a 6th. That's your y equation, but parametric equations come in pairs, so don't forget your x equation, the one we wrote earlier, negative 2t plus 1. You need both of them to go to parametric form. So now you've gone both ways. Now you can go back to Canvas and do your assignment for today.